Hello there. I'm taking a little detour from my usual lesson building approach to video making, and I want to go over this video. I had a video on multiplying binomials with radicals, and I wondered what would the result be, because I've never actually done this before, of multiplying a binomial of radicals but with different index. And so I tried to make it as simplified as possible. I gave it a look of being a conjugate, so we got the plus and the minus. It's not an exact conjugate. Each side has a cube root and each side has a square root, but with different insides. So let's talk about this. Let's go ahead and use our approach. So cube root of 2 and square root of 3. So that's that. And then I've got the square root of 2 and the negative cube root of 3. So I'm kind of interested to see this, and I haven't even practiced this ahead of time. So you're seeing this problem worked out live for the first time. Okay, now usually when we have radicals, if this cube root right here was, say, square root of 2, we would just do square root of 2 times square root of 2. But now we've got the different indices. I recall from properties of exponent that the cube root of 2 is just equal to 2 to the 1/3. And then I recall that square root of 2 is just 2 to the 1/2. Well, what I'm effectively doing is taking 2 to the 1/2 and multiplying by 2 to the 1/3. Because they're common bases, this helps us out great. I can add my exponents together. So 1/2 plus 1/3. In finding a common denominator, I get 3/6 plus 2/6. So that's 5/6. So ultimately, this ends up being 2 to the 5/6. Okay? Or if we wanted to, we could write this as the 6th root of 2 to the 5th. But I know 2 to the 5th to be 32, so the 6th root of 32. And because 32 is a perfect fifth, and I'm taking the 6th root, there's no way to simplify this. So this is the 6th root of 32. Now this works out nicely because I've got the square root of 2 times the square root of 3. That's just the square root of 6. Those have the same radical, so I can multiply the numbers inside, and they're both positive. Now, and same here, I got the cube root of 3 times the cube root of 2. That's the cube root of 6. And pardon me, it's negative cube root of 6. And now we've got the similar situation going on here. Cube root of 3 times the square root of 3. But that's just going to lead to the same situation as what I have over here with the base 2. So it's going to lead to the same math. The power is going to be 5/6. I can write it out as 6th root of 3 to the 5th. And 3 to the 5th, I believe, is 243. So we got the 6th root of 243. And, of course, the negative out in front. And none of those simplify. And none of them simplify within themselves or are like terms with others so that we can combine them together. So I have to just list out an answer of 4 terms. I'll write the 6th root of 32 first. So I wrote it so that the 6th roots are together, and then I'm going to add the square root of 6 and then subtract the cube root of 6 as my final answer. If you like this video, go ahead and give it a like and subscribe. And if you'd like to see other videos in the future, leave a comment in the comment section. Otherwise, thanks for watching.